Lesson number 22, daily summary. In this lesson, we learned how to graph quadratic equations. 0, recall the intercept method for graphing a line. Fill in the table in order to graph the line 2x minus 3y equals 12. Let's try that here. You can see that in the first row of this table, x is 0. So I'm going to copy this original equation right up here, but I'm going to change all of the x's to zeros. So here's everything in the equation copied except for the x, which becomes 0. And now we just have a little bit of algebra to do to find the corresponding value of y. 2 times 0 is 0. 0 subtract 3y is just negative 3y equal to 12, and then divide by negative 3. And we get y equals negative 4. So that goes right there. And that means we have the point 0, comma, negative 4. Similarly, now in the second row, y is 0. So let's go ahead and take again that same blue circled equation and change the y to 0. So here I am copying the whole thing, 2x minus 3, and then instead of y, we're going to put 0. 3 times 0 is 0. 2x minus 0 is just 2x. So if 2x equals 12, then x must be 6. Put that right there. And this is now the point 6, 0. And we can plot our 2 points. 0, negative 4. That's the y-intercept. And then 6, 0. That's the x-intercept. And then we connect the dots with a straight line. Or we come close to connecting the dots with a straight line. And that's the graph of the equation, 2x minus 3y equals 12. As we saw early this semester, the way to find the y-intercept is to let x equal 0, and the way to find the x-intercept is to let y equal 0. This is true for lines, and it's also true for the more complicated graphs we'll be exploring in this lesson. Number 1, in this lesson we will graph quadratic equations of the form y equals ax squared plus bx plus c. We call the shape of the graph of a quadratic equation a parabola. And so we're not going to go through all the details on this page, but I will just show you that the 3 curves that are here in different colors are all parabolas. And they're obviously much more complicated than the straight lines we've spent a lot of time graphing this semester. In order to graph a straight line, you just find 2 points on that line and connect the dots like we did on the previous page. But we're going to end up plotting 5 points on these more complex curves here, again, called parabolas. So you can read through some of the key features down below. We're just going to jump in to number 4 here, where we'll actually do a problem all the way out. So let's take a look at the equation. It says, here's how we sketch y equals negative x squared plus 4x minus 3. We'll use the 6-step process detailed on the next page. So the very first step is to decide if the parabola opens up or down. Is it a smiley face or a frowny face? And it turns out it's really easy to decide whether the parabola opens up or down, and it just matters the value of a. Now remember, a and b and c are the numbers touching x squared, x, and then the constant in that order. So the number touching x squared is negative 1. It's invisible, but I see that negative sign there. And the number touching the number touching x is 4. That's the b. And then the constant term not touching any x is negative 3. And that's the value of c. Make sure you grab the negative signs with these numbers. And so to decide if this is a happy smiley face parabola or a sad frowny face parabola, we just need to know the sign of a. And in our case, as we said, a is equal to negative 1, which is for sure a negative number. And on the next page, you can take a look if you want. It says that if a is positive, then the parabola opens upward like a smiley face. And if a is negative, like it is here, then the parabola opens down like a frowny face. And so because this value of a is negative, we know that our parabola opens downward. Next up is to find the y-intercept. We know that to find the y-intercept for any equation, we let x equal 0. So all we're going to do is change all of the x's to zeros. You can see it right here. All the x's become zeros, and therefore this whole calculation becomes negative 3. And so the y-intercept is x equals 0, y equals negative 3. Let's go ahead and plot that point on our grid. 0, negative 3 is the y-intercept. Next up is the x-intercept. To find an x-intercept, we always let y equal 0. So we're going to copy this entire equation here, but we're going to make one change, and it's the y becoming 0. And then we have to solve this equation. Now, solving this equation is a lot tougher than solving the Y-intercept equation. Here we have to do a bunch of algebra, but we have recently learned techniques to solve equations that look just like this. Equations with x squared in them. Oftentimes you want to get 0 on one side. Hey, it's already done right there. And we ask ourselves, how can we factor the right-hand side here? And our three kinds of factoring we always do in the same order. First up is greatest common factor. The greatest common factor of these three terms is 1, so that's not helpful, but it's worth looking for. Second thing we look for factoring is the difference of two squares. Is the right-hand side here 2 terms? No, it is not. It's 3 terms, so right away difference of 2 squares is off the table. So then the only other kind of factoring we have at our disposal is the 2x2 box method. And so you go through the details of the 2x2 box method, and let's start filling in here. You can see that the negative x squared has been copied in the top right. That 4x we're supposed to put over here with the sum. The negative 3 has been copied in the bottom right. I think I said top right before for this one, but that's top left. And then we multiply the two things on the diagonal, and we know that that's the product of the two blanks on the other diagonal. So we're looking for two things to put in these two blanks whose product is 3x squared and whose sum is 4x. And hopefully we see 3x and 1x is the winner. They multiply to 3x squared and they add up to 4x. You could put the 3x and x in either order in those two blanks. Then we will look in the first row and pull out the greatest common factor. I see an x in both, so let's pull x out. And that's it. The greatest common number factor of those two terms in the first row is just 1, so just plain x. Then we're going to come up here and we're going to figure out what do we need to put in that blank up above so that this x multiplied by this blank gives me negative x squared. Well, that blank must be negative x. And then we'll look at the 3x in the box. We know that that 3x is supposed to be the product of whatever we put in this blank and this thing way over here. So I think right up here we're supposed to put positive 3. I like putting the signs on all of my entries here. And then finally the last blank is down here. Looking at this x, it is supposed to be the product of whatever is up here and whatever we put in this blank space here. So I think we just need to put a negative 1. Negative 1 right there, because then negative 1 times negative x gives me positive x. And then we look at the bottom right and cross our fingers that everything worked. Positive 3 times negative 1 is negative 3. Of course it works. If you do everything right, it will work. But if you made a mistake, that might be a good place to, good way to catch your mistake. And so then we will copy the stuff on the outside inside parentheses, x minus 1, negative x plus 3. But this was an equation before, so it's still an equation. Don't forget that equals 0. And because it's equal to 0 and it's factored, we can now set each of the individual factors equal to 0. So either 0 equals x minus 1 or 0 equals negative x plus 3. Let's add 1 to both sides of this first equation. So we get 1 equals x. And then adding, I'm actually going to add x to both sides of the second equation. That makes the x positive on the left. And then the 3 stays right where it is on the right. So those are my two x-intercepts. I'll write them as ordered pairs, 1, 0, and 3, 0. It is not 1, 3. These are both x values we found. And we found them by initially making the y equal to 0. So that's why the y's are both 0. Let's go ahead and plot those two x-intercepts, 1, 0, and 3, 0. So we're trying to imagine this parabola that we're building here. And if you try to imagine like a smiley face parabola that hits all of these points, well, like, I mean, I could hit the first 2 points, right? Like no problem, but then parabolas don't turn around again. They only turn once. And so there'd be no way to make this thing go back down, not as a parabola. I could hit the other 2 points, for example. I could go like here and then here, but then I don't have a way to hit this one. Well, the mistake that I'm making here in my mind is that I'm trying to fit an upwards opening parabola to these 3 points, but we established in the beginning that this parabola opens downwards. Oh, okay, I can make a downward parabola hit these 3 points, something like that. So the question is, where is this top point right up here? So I'm gonna draw a parabola that roughly hits these 3 points. Don't copy this one just yet because there's some unknown stuff here. But here's something, a vocabulary word for us. Every parabola that opens downward has a top point, a highest point. This guy right here is called the vertex. So the top point on a downward parabola is called the vertex. Likewise, if your parabola opened upward, it has a bottom point, and it is also called the vertex. And our job is to find the coordinates, both of them, of the vertex. So how are we supposed to do that? Well, take a look at the parabola I've drawn here in green. Now, I've drawn it as if the the vertex was that orange point right there, but I don't really know exactly where the vertex is. Like, for example, maybe this parabola was a lot narrower and taller than I made it out to be. Maybe it's like way up there. Maybe that's the vertex. But in either case, hopefully we can see what the x-coordinate of the vertex is. The x-coordinate of the vertex, the way that I've drawn these two pictures, is x equals 2. Now the y could be different. I've got two different points up here where the y is different, but in both cases, I'm hoping you believe that the x is 2. And the reason that we know the x has to be 2 is that we know that the vertex has to be halfway in between our two x-intercepts, perfectly halfway in between 1 and 3. And the number halfway in between 1 and 3 is 2. So for sure, the x-intercept has an the vertex has an x-coordinate of 2. So let's write that. In this case, the value of 2 was obvious because the numbers 1 and 3 were really, really easy to use. But in general, how do you find the number halfway in between two other numbers? You average them. And so let's write that down here. It's actually written for us already. It's right here. It says you take the two x-intercepts, they were at 1 and 3, and the way that you average two numbers is to add them up and divide by 2. We're averaging two numbers, so this is always going to say divided by 2 when we're finding the x-coordinate of the vertex. And of course, 4 divided by 2 is 2. It's exactly the x-coordinate that we predicted just looking at our graphs. Notice the fancy notation we have on the left-hand side. It is an x-coordinate, so you better say x equals at the front, but it's not any old x-coordinate. It's the x-coordinate at that special point called the vertex. So I like to use this x sub b to indicate it is the x of the vertex. So how do we find the y of the vertex? Is the vertex way up high like we had it with the red point before? Or is the vertex kind of lower, closer to the x-axis? Well, we have an equation right up here at the top in yellow that tells you the y value for any given x value. So we're going to take the x equals 2 we just calculated and plug it into this yellow highlighted equation. That will get us the y value. So here it is. The y-coordinate of the vertex, there's that little subscript v again, is equal to, and all we did was copy that yellow equation at the top, but all of the x's, both of them, became x equals 2, and then we do the calculation. Be really careful here. This negative 2 squared, is it 4 or is it negative 4? It's negative 4 because that squared is not touching the negative sign. It's squaring the number 2 and then making the final answer negative at the end of the day. So we do the calculation. Negative 4 plus 8, that's, what am I doing here? Yeah, negative 4 plus 8 is 4. Subtract 3 is 1. So that's the y-coordinate of the vertex coupled with the x-coordinate of the vertex gives us both coordinates of the vertex, 2, 1. Let's plot that point. Okay, and we've got lots of information now about our parabola, and I feel pretty good that I could connect these dots with a nice curvy parabola. But there is one more point that I'm going to ask you to plot, and I will point out that every parabola has a line of symmetry. In this case, it's this vertical line going right through the vertex. And so our parabola, I'm going to draw it, but don't draw this thing just yet. But our parabola is perfectly symmetric about that vertical line of symmetry, meaning every point on the left side of that line of symmetry has a partner, a corresponding point on the right side of that line of symmetry. And so you can see that the two x-intercepts are partners of each other, right? They are symmetric over that vertical line. The vertex actually is the only point that doesn't have a partner, or I guess you could say its partner is itself. But every other point has a partner, including this y-intercept. And so I feel like we're sort of shortchanging the y-intercept by not plotting the partner. So that's what I want us to do last. That will be our 5th point here, is to find the partner of the y-intercept. And there's no formulas we're going to do. It's just logicking our way to the answer. In this case, in order to get from the y-intercept to the line of symmetry, I just need to run 2 to the right. So if I want to find the partner point on the other side, I just need to run another 2 to the right. And so that lands me right here. And the coordinates of that point, again, just by logic, 4, -3. So you keep the same y coordinate as the y-intercept, that's the -3. And in this case, we had to run 2 from the y-axis to that vertical line of symmetry. So you run another 2. 2 and 2 gives you the 4 for the x coordinate. And then we'll connect the dots with our parabola. There's only 2 things I'll be looking for when I grade parabolas, like after you've plotted your 5 points. Only 2 things I'm going to take points off for. One of them is this. That is not a parabola. A parabola is not pointy. A parabola is not 2 line segments, 2 rays, I guess. A parabola is curvy and smooth, so don't give me 2 things that are lines and meet up there at the vertex. Here's the other thing that I'll take points off for. So that is a very nice, smooth, curvy looking parabola. So why don't I like this? Well, the parabola doesn't stop just because we ran out of points that we plotted. The parabola goes forever. And so just make sure you don't stop at your last points. Extend your graph all the way to the edges of the graph paper. Don't go like vertical. Parabola is not vertical. But just a nice, smooth, continuous curve going all the way to the edges of the graph paper. If you like arrows, you can put arrows at the bottom. I don't need to see arrows, but just make sure you get to the edge of the graph paper. So on the next page, you'll see all of these steps written out in English, and so you're welcome to refer to this page as you do the activity and as you do your homework problems. And in the activity, you'll see that all the steps are laid out for you. It'll say first, does the parabola open up or down and why, and then second, tell me the y-intercept, and then third, tell me the x-intercept. So the process is all laid out for you in the activities. But anyway, here's your reference sheet as you work through those problems.